This is the BC610E transmitter from World War II, designed and built in the Hallicrafters factory. I restored this transmitter. This is the control panel with all the metering and the plate tuning control. It's got a 3-band selector so that you can pre-tune the exciter for 160, 80, and 40 meters, and with the flick of that switch the exciter is already tuned up, so all you have to do is change the tank coil, tune it, and you're on the air. This is the power control panel to select CW or phone. The phone position is supposed to lower the high voltage. I've kept it up at the CW level, and it also shorts the CW position, shorts the secondary of the modulation transformer. Beautiful old-fashioned rocker switches, and filament voltage and modulator bias can be adjusted. There are large rheostats, and then the fuses. And of course the transmitter is on casters. It weighs 410 pounds or so. I've got a Johnson Viking VFO to drive the transmitter with. And if you go around the back, there's the power supply down on the bottom with a pair of 866 mercury vapor rectifiers. This is a choke input power supply, and in the CW position it's 2500 volts under load, and in the phone position without the modification that I've put in, the voltage drops to 2000 volts under load. Then the middle deck is the modulator deck. That also contains the transmit receive relay, which is basically the primary of the power transformer. The plate transformer is controlled by that relay. And there's a heating element. You've seen those cone heaters, those radiant cone heaters. Well, this basically is used as a resistor to put in the series with the primary of that transformer to lower the voltage to about 1000 volts when you're tuning up the transmitter, so that you don't damage the final amplifier. Those are the 100 TH modulator tubes, Class B push-pull with the modulation transformer in there. Beautiful heavy iron. This is what makes a real old-fashioned transmitter. A pair of 2A3s. I'm not happy with the driver of the 100 THs. It really does not provide enough power and low enough impedance to drive the 100 THs without distorting the waveform. So that's why I've got these clip leads on the grids of the 100 THs, and they go to my kilowatt rack, where I've got a beautiful 2A3 driver with very low impedance. Has a different kind of driver transformer. So yeah, and there's the relay, the transmit receive relay for the shorting the modulation transformer secondary in CW position, and also to change the bias or remove the bias from the modulator tubes, a very high bias when you're in CW position. There's a bleeder resistor in there for adjusting those tap points. And then the upper deck, you can't really see it right now, I gotta open the door. In here is the tank coil and the tuning capacitor for the plate circuit of the 250 TH tube, which you can see in there. Glass tube. I'm going to turn on the power actually so that you can see the filament glowing. So we're just going to turn on the main power. Okay, this is what it looks like when it's turned on. You can see the 100 TH is beautifully glowing, and the 250 TH, which is sitting in there on the top deck, the exciter and PA. And the other door is the exciter, and you can see the tuning units in here. Let's do it the right way around. So these are the 3 tuning units, which correspond with the 3 positions on the band selector switch. So you can pre-tune these They're basically a 6L6, 6V6 oscillator or buffer if you're using the external VFO, a 6L6 driver or pre-driver, and then and a doubler. It actually does double the signals, and then a pair of 807s, which are the driver for the 250TH, which is back there. Okay, so you can pre-tune this. I've got a crystal in the middle. This is the 80 meter tuning unit here, and I've got a crystal on 3885 kilohertz. So yeah, and then on this side you've got the voltage regulators. If I just turn on the high voltage protect just to make sure I don't damage anything, and we'll just apply the exciter for now. So you can see the exciter current set at 100 milliamps. You can see the voltage regulator tubes glowing purple. Okay. So we're on the protect side, so that won't damage anything. Let's just see what happens. When the door is open, any doors open, the primary relay will not operate, so that you can't get plate voltage from the. That's a good safety feature, so you don't get a shock by putting your hands in there. So let's try it again. There we go. And we'll dip the plate. See? I'm just tuning here. There, it's dipped 100 mils or so. And then we'll go to the high. We'll take off the high voltage protect. And now we're putting out the full power. And you can see the RF ammeter showing almost 3 amperes of RF current in a 50 ohm dummy load. So you can calculate the power on that. And there's a barely perceptible reddish glow on the 100 THs. The mercury vapor tubes are glowing purple. And there's a very dull orange color on the 250 TH. And that's it. Transmitter's loaded nicely. I can probably increase the loading a little bit. There. 250 mils. Make sure it's dipped. That will give us a little bit more plate color on the 250 TH in there. So there you have it. A World War II Hallicrafters BC 610 Model E transmitter. It was used at Pearl Harbor to contact the mainland of the United States when it was attacked, December 7th, 1941. And it was used in the Battle of Midway in the Pacific. So this particular unit has a lot of history. The Hallicrafters BC 610E.